right, everyone, welcome back. We're joined today by two very special guests coming all the way from the NSF. Would you all please introduce yourselves and let us know what you do?
Hi, I'm Cliff Weil. I'm a program director in the Genetic Mechanisms program in Molecular and Cellular Biosciences at NSF, and all the way just met across the river. So.
Yep, I'm Amanda Simcox. I go by Mandy. I'm Cliff's colleague, but in a different division. I'm in the division of biological infrastructure, and I work in the human resources cluster. So we have something for every training and career level for scientists, support mechanisms.
So we actually already have a question coming in. What does it mean, a division, and what does it mean, the cluster, and how do you choose where you go?
Interesting. So I've heard the best analogy, it's like a university. So it's organized, by colleges and then departments. So we're both in the directorate for biological sciences, and then we're in different divisions. So Cliff is in one of the research divisions, and I'm in something that supports all of the divisions because we deal with infrastructure.
Yeah, directorate is sort of a college, and the divisions are more like the departments. And then within that are little groups of people sort of specialized by interest groups. So I'm in a genetic mechanisms group. There's a group that does cell biology. There's a group that does synthetic biology. There's a group that does molecular biophysics in my college.
And so I guess that's another follow-up to that is having that background. What is the background that y'all have in order to gain a job like this? Like, did y'all go to graduate school, do a doctorate in research, and now are an expert in that topic? How does it translate in your education to get to this stage?
So I think both of us, well, Mandy still is a faculty member. I think I was. I'm retired now, but it's the same sort of academic track into faculty jobs, and so PhD, postdoc, faculty job. And then at some point in the proceedings, somebody approached us, or we got interested in, after being on a bunch of grant panels, working at NSF, and you apply for the job and you interview for the job. It's all that sort of.
Yeah, and it's interesting because it's sort of, you have a typical academic career, but you interact with these funding agencies and you meet people, and then whenever you serve on a panel, they advertise this rotators program. So you go there for about 2 years at some point in your career where it really fits, your lab won't go sideways if you leave for a little while. And you typically do a rotation, and then if you like it and they like you, and then you see a permanent job come up, you might apply for that. So there are two kinds of program officers at NSF, the rotators who are temporary, and the permanents who have permanent jobs.
So you mentioned that you're still faculty. Does this
I'm actually
mean
emeritus.
And so
Yes, but I have a lab, and if I have to say one amazing thing about being a program officer at NSF, it's that they really respect the fact that you still do research. So they know that if you're active in your research community, you'll be a better steward of proposals that come in and the whole process. So I can actually go to my lab at Ohio State University, very small lab, small enterprise, but it keeps you engaged in that intellectual thing, which is amazing.
And so can you talk a little bit about what is, like, as you're an advocate now for science and also like the science funding and like awarding funds, how does something like that work? Like, do you just get a proposal on your desk and you have to decide a yes or no? Like, what is the background process for people to understand? Like how, someone mentioned in chat that there should be more funding for science, right? So it's like,
correct.
Amen.
Correct.
So I guess with the amount that we do have, how does one decide, what gets something, what doesn't get something, and what's the process behind it?
So people send proposals into us, and we accumulate them over the course of several months. And then we'll convene a grant panel, which is usually inviting anywhere from 8 to 15 or even 20 experts in. And then we'll distribute those proposals to that panel. We pick them on the basis of geographical distribution and expertise, and whether they're full professors or assistant professors in small colleges and big colleges. And then we send them these proposals and they review them, usually 2 or 3 of them per proposal. We write to people outside of the panel to get what we call ad hoc reviews. And then We all sit down and discuss the reviews, and the reviews are sort of advisory to us as program directors. And then after the panel is over, then we as program directors look at how the panel ranked them and reviewed them, and look at what we currently have funded, so what we like to call portfolio balance, and then make funding decisions based on that.
So the programs that I work in actually have deadlines. I work in postdoctoral fellowships, something for new faculty, and research experience for undergraduates. So we have actual deadlines, and people submit for that deadline, and then the process is the same. NSF is pretty famous for having the gold standard in merit review. So every proposal that comes to NSF is reviewed for its intellectual merit, the science, and what it might do in terms of broader impact, societal benefits. And yeah, that sort of sets it apart.
Training and broadening participation in science as part of broader impacts as well.
So would you say there's a focus on early career scientists, or is it just also a general for the different stages?
It's every stage of your career, and then, you know, Cliff's in a research specialty area, and that would be at any stage.
Yeah, so we fund people to do work into K through 12 schools. We fund people to do work with let's talk about high schools, but undergraduate research, graduate research, postdoctoral fellowships, people who are early in their faculty jobs, mid-career faculty jobs, so pretty much cradle to grave.
A question from Chad is, how do you decide how much money to give someone?
Depends. In the program, at the postdoctoral fellowship, the current solicitation, the salary is $60,000, and then there's a $20,000 research allowance. So nobody who applies is thinking, how much money do I need? It's a set budget. Other programs?
Yeah, so some programs have caps. They just set so that, you know, we can't give $50 million to everybody. But basically, people ask for what they need to do the science they're proposing. So the number of people they need, the materials they need, maybe a piece of equipment they might need. And so they range anywhere from a few $100,000 up to a couple $1 million, at least in the program that I'm in now.
A follow-up question that Chad is, how does one decide which one should get more or less? And you have to evaluate that. You mentioned that earlier in the stream today we talked about mice versus flies versus worms and the prices of those animals. You have to take those things into consideration as well when getting these review packets, and how, I guess the crux of the question is, how do you keep up with all of these different moving parts and decide, you know, what does someone need versus what someone might want?
People are pretty good about asking for what they need. It's very rare to find somebody who pads their budget for, you know, just for fun. Most people recognize that the amount of money we have is limited, and they try and make the best use of it. So they won't ask for things just to have them. For the most part, it's, I need this to do the science. And they have to justify it in writing as part of the proposal. So we can tell.
And the review panel look at that. It's not really a driving thing in, you know, how they would score a given proposal, but they look to see if the budget's reasonable for all of those reasons.
So pulling back the curtain a little bit, Cliff, you mentioned that some of the criteria for choosing these reviewers, proposal reviewers from different parts of the country and different institute sizes, why is that beneficial to do, and what is your ideal panel comprised of?
So why it's beneficial to do, I think, is that people have a wide variety of perspectives, and it's not just science. So a lot of what gets reviewed, as Mandy was just saying, are these broader impacts and training ideas. And so to have a bunch of people from very large, very well-funded institutions trying to judge proposals from schools that are smaller and are solely undergraduate institutions is sort of a little bit of a mismatch. And so having people from all the different institution types as part of the panel is really helpful. Having people from a broad demographic is really helpful. Gender balance, ethnic balance, geographical balance, all those things I think impact somebody's perspective on the science. And so one of the things that makes the NSF review process, I guess, as good as it is the fact that there's always a lot of perspectives looking at the science. So I think that's why it's important to do. What was the second part of your question? I forgot.
So it's, what is your ideal panel
The ideal
comprised of? Yeah.
We strive to have 50% female panelists. We strive to have ethnic representation that approximates what the population of the country is. We strive to have people that are from large institutions, from small institutions, from different parts of the country, and basically as broad a representation as you can within the confines of having 50 people. Right? You can't have,
And also, looking at what their scientific background is. So you want to match the scientific expertise to the
With what's in the
expected pool of proposals.
And a lot of times we don't pick them until we've got the proposals in hand.
Yeah.
So we have a sense of what the science is going to be that we need reviewers for.
And to Cliff's point about, matching the review panel to the types of proposals, one of the programs that is one that I'm involved in is targeting new faculty at non-R1, so not the most research active institutions. So the last set of people you really need on that panel is all the people coming from the excluded set of institutions, so matching the expertise to targeted, institution type that's in that particular program is key.
We have another question from chat. Diversity in STEM is very important to me. What does the NSF do in terms of funding to promote this?
Yeah, so I can talk about another program that I'm involved in. It's the Postdoc Research Fellowship Program. One of our longest tracks is called Broadening Participation, and it supports any kind of biology, any biology question, but another goal of that program is just to increase diversity at the postdoctoral level. So by, the trainee themselves who's applying for that, or what they're going to do to promote diversity for other postdocs, that's how we try and broaden participation in biology at a specific level, in this case postdocs. It's a very important aspect at NSF. You know that talent is everywhere, but opportunity is not. You can read our strategic goals and you'll see those kind of ideas, and the recognition that there are lots of institutions in this country, in this nation, but they're not equally or proportionally represented necessarily in the current portfolio. So one of the goals is to reach those missing millions, is the sort of catchphrase.
That person in chat said, "Thank you for what you do."
Thank you for your question.
That's right.
Yeah.
Another question is, how has the academic funding landscape changed in your time and your position? Have there been any big events that have moved it towards better or worse?
Well, it seems to be, it's always in flux. That's the one thing I have a much better appreciation for now that I work at NSF. As we said earlier, there can always be more funding for science. There should be more funding for science. We try and work within the budgets that we get. And the budgets that we get are, sometimes they go up. A lot of times they stay flat. Sometimes they go down. These days, we're hopeful that anybody will just come up with a budget and not continue to fund continuing resolutions all the time. So we basically would like to see more money come in so that we can send more money out. NSF is really good about sending the money out the door that we get in the door. Something like 95% of what comes to the agency goes back out in grants. And so we would love to see some increase in the funding for science. That would be great.
Yeah, I think when you know that NSF funds, we're biologists at this conference, but NSF funds all of basic fundamental science, physics, chemistry, engineering, with a pretty slim budget, in terms of what we actually really would like to have. But anyone, watching the news knows that everything a federal agency does is tied up with Congress and the appropriations. So yeah, but currently our budget's around $9 billion, I think.
Something like
Yeah.
that.
So a follow-up question on that is, I would really like to have cancer cured. How can we get more funding for the NSF? Do you have a say in how much money the administration gets, or can I call someone and make a difference?
Yeah, you call your congressperson, your senator, your representative. We cannot lobby anyone. We are employees of the government. There's the Hatch Act that prevents us. You know, we can't sit here with a hat on that's got some political affiliation. It's absolutely your caller's job to get on the phone or send an email, and they actually really, these sort of anecdotal things, if you explain why you think this is so important, they read that stuff and it actually does have an impact. Yeah.
And a lot of the biology that we fund, we're actually pretty careful about not funding things that are directly related to treating diseases. That's NIH's job. We, I think as Mandy said, have to fund everything else, and with only a fraction of NIH's budget. But a lot of the basic biology that underpins a lot of the studies in diseases are things that we do fund.
So a follow-up question is, when a new technology comes in, do you have to form a new unit to assess that technology for funding? Has there been any allocation for, let's say, AI, which is considered new, or is that still more primarily in the private sector?
It's definitely something NSF stays at the forefront. So there are all these AI institutes all over the US, and you know they are supported by NSF and other federal agencies as well. NSF tries to stay on that cutting edge, and that's part of the reason I think they have the rotator program. So you know there are card-carrying scientists working at the NSF who've got their antennae out looking for developments. But AI is a brilliant example from that chat. Yes, definitely the answer to that is yes.
But at the same time, we don't spin up new parts of the agency to deal with new technologies all the time. So AI is something everybody is talking about now, but we have a computer information science and engineering directorate, sort of the same way we're in bio. It's called SIZE for short, who are kind of monitoring and taking care of that, most of what that piece of technology is. That said, AI is a special case because it's basically in everything. So, I mean, you can walk around this meeting and hear all about how artificial intelligence is impacting biology and the data that come in from image analysis or genetic network analysis or any number of places. So AI is pretty much in everything at this point.
And I think that brings up an important point about NSF. We are not siloed. So there are a lot of partnerships. So we told you a bit about the structure. You know, there's a directorate for computer information, SIZE, and then there's a directorate for biology, but we do things together. You know, bioinformatics, that kind of stuff is a partnership, and NSF does a lot of that.
There's a lot of that.
Cross-directorate programming.
That was actually part of the follow-up question is, when you get a proposal that has multiple avenues, so the chatter used the example of biology and then AI, do you just send it to one of these units or do you send it to multiple, and how do you decide who evaluates something that has multiple layers of complexity that could be very different?
That's a really interesting question because it turns out to be a really nice thing about NSF, which is it's a relatively small shop, right? I mean, there's a reasonably small number of people there. And if something comes in that looks like it could be evaluated by multiple people, we walk it around and show it to them. And there's a lot of what we call co-review. So we'll review something and the computer people will review it, or the engineering people will review it, or we'll review it within different parts of biology. There's a lot of that kind of sharing if something doesn't fit neatly into one of the boxes. And that happens a lot. Sharing
of the funding too. So if two entities are interested in it, it can happen because they're actually both funding it together, co-funding.
So would you say each entity has X amount of budget?
Yeah.
And there could be crossover, so if you're really interested in a project that maybe can't be fully funded by one silo, but maybe there's crosstalk, you can allocate for it together if it crosses over both.
Yep, and there are special programs, so all of the awards come with a public abstract that actually tells you where at NSF this is being funded. And there are special programs that we as program officers can send a proposal and say, we think this, would be supported by you, and they'll co-fund with us. So it's a way, when we get our budgets, we do due diligence and we look for these special other funding sources to try, but always trying to maximize the number of proposals that we can fund.
And it extends beyond NSF, so I'm part of a program called Enabling Discovery Through Genomics, or EDGE. We love acronyms at NSF. That's actually NSF partnered with NIH. And so these are proposals that will come into a panel that's part NIH, part NSF, and we all review it together. They get NSF scores, they get NIH scores, and those proposals get parsed out between the two agencies. So there's a lot of sharing of proposals and funding and review.
A follow-up question is, you mentioned a public statement. Is that something I can read?
Yes.
And what is, as a non-science expert, how can I better understand these points?
So these public abstracts actually have 2 paragraphs, and the first paragraph is a lay version of what they propose to do, and the second paragraph is more technical. And it's written, the first paragraph's written for someone who's probably had like 10th grade biology, so it's at a reasonable level. I mean, they're not the easiest reading material because there's sort of these concise little paragraphs and you have to find them all, but you could get a flavor. You can go onto the NSF website and you can search within a program and get these. You could definitely, if you were thinking of applying, it would be very good homework to look at what was funded last year to see if your ideas fit with that general kind of scope.
I think we've got another non-scientist question following up on that is, if I had questions about the work, is there someone I could ask?
Yeah.
Absolutely. I mean, we urge people to contact program officers all the time.
Is that for both scientists and non-scientists?
It's for anybody who wants. Yep.
Yeah.
So I could, as a scientist or non-scientist, I could send you an email and just be interested in what's going on and what the research is, and if I wanted to help in a way for fundraising or what have you, like y'all are public-facing figures that are available to people.
We are. As far as fundraising and things like that, we would probably send you to somebody else in the agency for that. But if you have science questions, certainly if you're someone who wants to submit a proposal and has an idea that they want to kind of see where it fits or whether it's good, what we encourage people to do is to write project summaries, just a page and a half, and send them in and let us take a look at them, and we can then let you know whether what you're interested in fits within a particular program, and if it doesn't fit with ours, we know who to walk down the hall and show it to. So we encourage that, and anybody who wants to contact us is welcome to do that.
I would say to your chat question there, also consider your local university. I come from a university that has an extension office. So, you look at your apple tree and the leaves have all gone yellow and you're wondering, is that, an insect, a fungus, something? There's lots of sources. I probably would go, if I was not thinking about sending a proposal, had a science question, I'd probably go to a university first.
So there's a follow-up point on there is, I always feel nervous to contact a scientist. Thank you for alleviating my fears.
Good, don't be afraid.
We don't bite much.
And I think this is for both of you. What has been the most rewarding funding that you have been a part of?
I think for me it's been 2 kinds, really. There are some proposals that come in that are just crazy ideas. Right? I think this will work. I don't know. It's kind of risky. If it works, it'll change the game. And a lot of times we will fund those and they don't pan out. But every once in a while they do. And I've been on a couple that did, and they were wonderfully rewarding. So that's one thing. And the other are proposals where people are doing really interesting attempts to engage either the public or undergraduates, or the things that I really like are the things where they go down into high schools and even elementary schools to get kids excited about science. And a couple of those, there's one of those guys is here actually at this meeting. Some of those pan out really, really well, and that's just wonderfully rewarding. I love those proposals.
Yeah, and I would say it's something, probably the postdoctoral fellowship program that I'm part of. So that's a more holistic look at the whole applicant. So you see these proposals where, so in the broadening participation track, they have amazing records where they've been serving a community, doing all these activities, and yet they're doing stellar research. And then they propose something for their postdoc that goes to another level or completely changes systems. And you know, the rare ones get an outstanding ranking and they can be called transformative. So if you read, you know, what NSF would like, they mention this word transformative. And I would say, you know, certainly not every panel, but there are those panels, and just get everybody excited,
Yep.
and they tag it as transformative. So I think those are the really exciting ones.
The chat's also agreeing that those are both sounding really exciting, and there seems to be a surprise that there is funding for science communication as well.
Oh, absolutely.
I guess, Cliff, would you mind going into a little bit of the detail about, like, what do you look for when there's a science communication opportunity, and are you looking for in-person, virtual? Could some platform like Twitch be something that people could be interested in and apply for?
It could, and people are amazingly creative with how they do this. One thing that I've sort of championed for the last 5 or 6 years, and there are a lot of other people, not just me, is that we as scientists are notoriously bad at communicating what we do to the general public. We're not even that good at communicating it to other scientists. But the ability to communicate what we do and why it's important is maybe one of the most important tasks we have as scientists. And so opportunities that engage science communication to the public or to young children, I think, are maybe 2 of the most important things we need to do. So any opportunities that show up in grant proposals that want to do that, we're all in.
And another program I'm in is called Research Experiences for Undergraduates. And these are cohort experiences for summer research. And there are a lot of professional development activities as part of those programs. And they have science communication. You know, they prepare that elevator spiel for, you know, someone who's not a scientist. They make posters. Some of them are in sort of museums, so they do public outreach. We get a lot of citizen science too. So, you know, there are many famous big entities where citizens are really contributing. But I think if you start as an undergraduate thinking about how do I communicate my science, that becomes a part of what you do at every level going up through your career, and it's not too soon to learn how to communicate. Yeah.
I'd love you all to answer on this. It's so cool to see that not only it's the science that's being done, but also how to communicate to the public. And it's almost a feedback loop. If you do it both right, it keeps going.
It really is. And I think one of the things that would encourage more funding for science is if more people were really excited about it. I mean, I quip to people that the 2 most important questions left in biology are so what and who cares. And I think it's really important that we convey to people why the things we're doing are really important to know, and why the world is a better place if we find some of them out.
And people are so hungry for that.
Yeah.
When I was a professor and actually had NSF funding, my broader impacts were to go to the Science Museum and show them glowing Drosophila larvae, expressing GFP. They gave us the planetarium.
Nice.
So we could bring in a fluorescent microscope and then project these larvae, where the planets should have been. And one of my colleagues was at the museum. I said, I'm showing these larvae. And he said, well, I've seen them before. And then he came in and he saw this giant thing in the planetarium. And there were people in the audience that knew so much about inheritance patterns, and they saw these things and said, well, will the progeny of that also be green? So there are people, this is people who are already going to a science museum, so it's a little bit selective, but people are hungry for this, and it's our absolute job as scientists to share and not stay in our ivory towers. Yeah.
Plus, I think, most of us in science have some moment, probably back when we were 8 or 9 years old, if not younger, that the light bulb went off, and something just really caught the awe and the wonder of science for us, and that's why a lot of us ended up following that. And the ability to convey that to people that's just magic. I mean, that's what most of us are teachers of art, and so that's the magic of teaching, is that moment when you see the light bulb go off over somebody's head. And so the more we can convey that about science, the happier we are.
I love how both of y'all have kind of hit on the comments as they were coming in and answered them. So one comment is, I'm glad to hear an emphasis on communication, especially to children like my small nieces. Or another one, I think the more science communication there is, the more public support for funding would also arise. And so the moment actually you said that, Cliff, is like the comment came in at the exact moment. So it's people,
ESP is a wonderful thing.
It's scientific.
We have another question. I guess getting back to the undergrad funding,
yes.
I'm at a school that's considered low level compared to other schools in terms of my undergraduate, but I still want to be able to make a difference in science. Does the school that I'm at make a difference for funding in the future if I want to go to graduate school?
No, and what I would strongly advise this person to consider is doing a research experience through this program that I just mentioned, the RU program, because that program is absolutely designed for students who have not had an opportunity at their home institution to do, authentic cutting-edge research. Those are exactly the kind of students who have an interest, as your caller or your chatter has, in science, and that's exactly who these are designed for. It absolutely will not count against you, but show the initiative, go out and seek an opportunity, and you will actually have a stronger application because you haven't had everything sort of handed to you, you've sought it out. But no, in fact, REU programs, one of the things in the solicitation actually says, community college students are really encouraged to be part of this, because community colleges, often 2 years, don't have a research opportunity. So, just go for it is the answer to that.
I guess there's a follow-up on it. It's, I took time off after high school to go into the military, and now that I'm an undergraduate, I'm thinking more about my future. Am I at a disadvantage for being older and having worked in a different field if I want to continue in science and look for this type of funding?
Not at all.
Advantage.
Yeah.
So NSF actually mentions veterans in the call for many proposals. People, in science generally, and certainly, reviews, they recognize these life experiences and how they mature someone. So this, your chatter, I'm going to call them chatters, has already thought about things and decided science is probably my path, from a much more, well thought out perspective. So this would be an advantage.
And I think we have a graduate research fellowship program that Mandy's also involved in. And those are awards, they're a little about the science, but they're mostly about the person and the perspective that person brings to the science. And someone like that has a very interesting and different perspective on why they want to go into science and what the science means for them and what their opportunities haven't been and are now. And those are really strong proposals.
Yeah. The fellowship program, so the graduate level one, the postdoc one I was talking about, they're about the applicant, about your story. If you tell your story that, and how maybe there were hurdles in your way, you got over them, and this is what you've done. Yeah, it's powerful stuff.
Another, I guess, some people are very excited about these prospects, and it's like the first time almost hearing about it, because, like you said, sometimes it's hard to get to the public of some of these points. Where do I find these type of applications, both from a personal perspective as a non-scientist, and if I become a scientist, where do I find them?
The website.
Yep.
The website, yeah. If you do, it's always so nice if you are in college or something to talk to a knowledgeable professor. I was an advisor for many years, so students would come to me, and it's really nice to have someone, sitting there with you, giving you a few pointers, but doing it cold turkey by looking at the NSF website can be done.
That's a good place to start.
Yeah.
And a lot of times if you go to a search engine and you type NSF and kind of the words you're interested, it will take you to places that will start to give you information.
And I can tell you for the REU program, which maybe what some of your listeners are interested in, if you type in research experiences for undergraduate, NSF, National Science Foundation. The top hit is actually REU sites for students. It's the student site. It takes you to all the different programs, and you can select by state, by topic area. So you could decide, you live somewhere really cold, you want to go to Florida for summer, you're a neurobiologist, so you type in 2 keywords, Florida and neuroscience, and see if a program matches.
A follow-up question is, I consider myself a citizen scientist as an avid birder. If I were to want to get funding for this, do I need to be affiliated with a university, and do I have to be in the United States?
So you do have to be affiliated with, not necessarily a university, but some research entity usually, or educational entity. Do you have to be in the United States? Sort of, but not always. There are different ways around that. But I think it would depend on the kinds of things the person wants to do. So if the person wants support for their birding hobby, we're probably not going to fund that. If they're interested in doing some sort of research on birds, there are usually ways, if they aren't at a university, that we can get them connected to someone who can help them.
Cool. So I guess for the individual person, like if they had a business that was a nonprofit, like an LLC or something, that is more likely than just an individual person who has a hobby that's involved. So it's like there's a mission statement behind some kind of business entity.
Yeah, NSF makes awards, to institutes of higher education is the most typical, some non-profit, some other kinds of entities.
There's written who's eligible to apply.
And then, at your institution, you have to have PI status, be a principal investigator. So there are definitely, some parameters.
A question I think in Chad is very pertinent is, what got you interested in working for the NSF?
For me, I was a director of one of these research experience for undergraduate sites at my home institution, which is Ohio State University. So I'd run a summer program. As part of that program, directors of sites went to a meeting organized sort of by NSF, and then I met program officers, and it can be very influential to meet one-on-one with a program officer, and if they like what you're doing, how you're running your award and your research site, they might say, consider doing a rotation. And that's sort of how it started for me.
For me, it was when I first started as a faculty member back in the early 90s and got my first grant. Shortly after that, the program director that gave me the grant asked me if I would serve on a panel, and I sort of felt like, well, I owe it back to the community to do this. And while it was a lot of work, it was absolutely exhilarating to read people's best science and talk about it with really smart people. And I was hooked. And so 20-some panels later, when I had the opportunity to come actually work at the agency, I thought,
that's definitely the main entry point, is serving on a panel. I have done a lot of that too. And again, NSF really values their reviewers because they're doing so much work for the scientific enterprise, and always has a leadership visit. So someone from the leadership at NSF will come and talk about the rotator program. I'm not sure what the numbers are, but I think it's maybe 60% of rotators and 40 of them.
I think it varies depending on where the agency is.
But it's a lot of people.
There are a lot of rotators.
Are on loan essentially from their institutions working at NSF. So there are lots of opportunities. Once you're, on your academic track at the right point in your career, to dedicate 2 years to science at the national level. I mean, that's the attraction. You've done science in your lab and it's super interesting, but if you want to do something at the national level, NSF is a perfect opportunity.
It's a very impactful job to have. And the rotating, this idea of rotators and permanent people permeates the agency. So the person who is the lead of our directorate, so the head of biology at NSF, is a rotator. And so a lot of times people in the senior management positions are also rotators. There's a mixture of rotators and permanent people there too.
So then new perspectives are always coming in, I would say, right? And these are people with an active lab as well.
Exactly.
So that actually touches on another question, is if you have an active lab in a different state, do you have to move to DC when you're doing this rotating, and or when you're permanent? Can you run both at the same time? Do you get paid for both? So I guess just some of the logistics behind it.
Yes. I mean, I'm permanent, but I can still spend a fraction of my time back at my lab. And with, coronavirus changed everything. There's telework now, so it's probably easier, given the current sort of, regulations about how much time you have to spend on site or off site. I think the answer to that question is yes. You will be able to keep your lab running, but know that your students and your other trainees will miss you.
Yeah.
They might be quite happy to see you go initially, but
they'll miss you eventually.
Yeah, in the end they will miss you, and so it's really important. And luckily there are lots of ways, you can have your lab meetings by Zoom, and you do get to go back often. But again, I think that's why I said choose when you're going to do it at a critical point in your career where your whole lab won't go sideways if you leave. So your students have to be sort of trained in a good faith. So there are lots of things to consider.
You get 50 days a year to go back to your home institution and work on your own research.
Which is 1 day a week. It's a 20% thing.
Yeah.
It's decent.
And so
Yeah.
people usually manage to string a number of days together so they can go home for an entire week or work it around going to conferences. There's all sorts of ways to do it. But I think one of the things that is proved important in my experience and in the experience of other people I've talked to is to have someone in your lab who can sort of serve as middle management.
Yeah.
So a senior postdoc or a technician who's been there for 20 years or someone who sort of knows the operation pretty well on a day-to-day basis. You can have lots of contact with your lab by remote, which is great, but there's something to be said for having somebody who can run the store.
Definitely.
In the store.
Not everyone has that luxury, but that would be wonderful.
I guess a little fun question is, since you live in DC now, do you miss your home institution or home state? And what about that home state do you miss the most living in DC?
So I love living in DC. I liked moving. I lived in small towns for decades, and I discovered that, much though I didn't want to admit it, I'm probably a city kid at heart. And so I love living in DC. I moved here from Indiana.
There's actually, in chat said, for Dr. Cliff, do you miss the cornfields of central Indiana?
I do miss the cornfield, not necessarily the cornfield of Indiana, but I do miss being in the cornfield. That's a whole other story about one's relationship with maize as a biological system to work in. But the thing I miss most about Indiana is my kids. Well, one of my kids is still there. I do talk to her all the time, but I do miss being down the street. And
so I don't miss anything yet because I live in both places still, which is amazing. So I live in Chinatown, which is really DC, and it's a hopping kind of neighborhood, very close to the mall. It's a wonderful place, great restaurants. You can walk to the mall in 15 minutes from where I live. And then when I get to Ohio, actually my cat lives in my house on his own with an automatic feed thing and stuff. So I'm very connected still, from Columbus, which is a great city. It's a great city actually for that sort of 20 to 30 something demographic. I think people in that age range really love it because it's expanding. So I guess I'm a Buckeye, at heart. And from my office there, I can see the stadium. So, yeah.
Someone in chat goes, a very lucky cat, too.
Oh, really? I know, honestly, it's ridiculous, but there you go.
I think this might be a good question to round out our discussion today. This has been very refreshing to hear, and I'm really happy to hear the existence and opportunities of the NSF. Could you comment on something that you are most looking forward to in the coming year, whether it be a funding opportunity or something that you're going to be doing with the agency?
I can tell you, so we're at the Allied Genetics Conference here, so this is a highlight for sure because I'm a Drosophila person, so I'm part of one of the communities that's at this GSA meeting. But future meetings that I have lined up include SACNAS, Abricams, and ACES. So these are diversity conferences, and you see, what an amazing set of scientists there are out there. So I really am looking forward to those. I always do.
And I'd say there are really interesting kinds of science that we're looking very hard at NSF and trying to figure out ways to get funding into. And Some of them are represented here at the genetics conference. Some of them are various kinds of plant biology. Some of them, since they're not formally announced, I can't really talk about them, but they're in directions of RNA biology and plant biology and genetics and genomics, and trying to think about genomes as four-dimensional objects, and just really kind of exciting things. Artificial intelligence is going to be required to even imagine dealing with those kinds of data. And all of that is sort of on the horizon. So it's kind of an exciting time to be doing this.
That's really cool. I guess just with your comment was one last, we'll sneak that in, is how do you decide what will be an up and coming thing to fund that you have, like they said, that you haven't announced yet, but it's going to be something really cool, and how does one decide these new kinds of funding announcements? Like, is it depending on the papers that are coming out? How does that work? And then a follow-up is, genomes as 4D objects. That sounds really amazing.
It is. And we decide, I think, the same way everybody else does. We monitor the literature, we see what comes in for proposals. We're all scientists and thinking about this stuff constantly. And so it's not that different than a university environment where everybody's talking about what the latest new thing might be, and thinking about interesting questions to ask and interesting ways to ask it. And so we're part of that community just like everybody else, and we make those decisions the same way everybody else thinks about what's the most exciting thing to do.
That's wonderful. Thank you all so much for your time today, for your insight. If folks wanted to contact you, would email on off your website be okay? We talked about accessibility.
Should we hold our badges up?
That's right.
Yeah, there's a lot of folks in there.
Yeah, so you just use our last name at nsf.gov, and just make sure you say you were part of this, and we'd be happy to.
Thank you all so much for your time and just being accessible, and for I barely had to ask a single prepped question. We just had folks asking the whole time.
Good questions.
Thanks for the questions.
Yeah, and with that, y'all, we will be back live tomorrow. Thank you so much for the viewers' time as well, for joining us, and for all your active questions. We had two sessions today. One was 2 hours, another was about an hour and a half, and lots of avid viewers and questions. So
nice.
thank you all very much.
Thanks for doing this.
Thank you all.